Hello everyone, my name is CMA Panktiveni. Welcome back to CMA Modules. Today I am going to record a video lecture on topic known as assignments. What is assignments? Let us try to understand in a layman language first with the help of an example. Now I am running a departmental store and I have vacancies for three employees, three people. So vacancies are in a different way. One is for salesman, one is for delivery boy, and one is for cash counter, computer, a person who is well versed with computer. So three jobs, three employees are required. So I have four people or three people standing in front of me, and they are okay with any jobs assigned to them. Okay, so what I'll do is based on their best capability, I'll start assigning employee A to job A, employee B to job B, employee C to job C. Okay, same way we will be studying in this topic also, but with the help of an example. With the help of sums, we'll be doing same thing. Here also we will be assigning. Here also we will assign batsmen to batting position, machines to respected job, salesman to respected jobs. Sums will come with different variants, but the basic agenda, what you will have to do is you'll have to go for assignments. Okay. Now assignment sums comes with two types. What are their types? First one is minimum. Okay, and the another one is maximum. Question will specify minimize, minimum. Question will have such type of words: minimum, minimize, maximize, profit, loss. Question will have such type of words which will help you to identify it is which type of sum: minimum sum, maximum sum. If it is maximum sum, different treatment. If it is minimum sum, different treatment. Different treatment in what sense? Only in one step you will have to go for different treatment under maximum. Rest everything is same. I repeat, there are two types of questions which you will get under assignment topic. One is minimum, another one is maximum problems. Minimum, how to identify sum is minimum? You'll have words such as minimum, minimize, loss. You will have words such as maximum, maximize, profits. Okay, so this is the way you identify whether it is minimum sum or maximum sum. Okay, now if it is maximum sum, there is only one extra step which you have to do that I'll take in next lecture. Now minimum sum or maximum sum, all other steps are same. Before starting question, my first step will be, they'll be giving you rows and columns here. Okay, they'll be giving you rows and columns. In other words, it will be a matrix. So as soon as you go for the question, what you have to do is you have to check your first step, your first checkpoint will be whether my number of rows and my number of columns are equal. This is column, L is standing, columns. This is row, horizontal. Rows are horizontal. So my number of rows are equal to number of columns. That is your first checkpoint. Check that. Okay, if they are not equal, make it equal. So what you have to check whether rows and columns are equal, that is whether it is a balanced matrix. If not balanced, make it balanced. How to make it balanced? That is the question which I have now. If suppose my row is extra, suppose I have here F also, my row is extra. Okay, I don't have extra column. Then you prepare extra column, you prepare a dummy column in your solution with 0, 0, 0, 0 and start with your answers. That's the way how we make unbalanced matrix a balanced one. Okay. So this was the introduction part. First checkpoint is to check whether my number of rows are equal to number of columns. Okay. Now I'll start with the question. A salesman has to visit 5 cities A, B, C, D and E. The intercity distances are tabulated below. Note the distance between two cities need not be same both the ways. So distance between two cities should not be same both the ways. Okay. Now coming down to the answer, the matrix part, from and to. This is from and to is given to me. From A to B, from A to C, from A to D, from A to E, from B to A, from B to B, from B to C. Okay, so the matrix is given to me. Note further that distances are in kilometers. If the salesman starts from city A and has to come back to city A, he has to start from city A. After doing everything, he'll again come back to city A. Which route would you advise him to take so that total distance traveled by him is minimized? See, here they have mentioned minimize. So this problem is for minimized. Okay. So how to go for this question? How to solve this question? Your first step will be, I have noted down question here. I have noted down question. After noting down question, what I did, I went for first step. What is my first step? Row operation. What is row operation? Row operation is nothing. Identify smaller number from each row. Identify smaller number from each row. After identifying smaller number from each row, subtract that number from respected row. For example, I'm identifying 12 as my smaller number here, 6 as my smaller number, 10 as my smaller number. So what I'm supposed to do, I'll take 12 and I'll subtract from entire row A. I'll take 6 and I'll subtract this 6 from entire row B. Okay. So 12 minus 12, 24 minus 12, 25 minus 12, 15 minus 12, 6 minus 6, 0, 16 minus 6, 10, 18 minus 6, 7 minus 6, 10 minus 10, 11 minus 10, 18 minus 10, 12 minus 10. Okay. So that way I'll identify my row operation. After doing this, see, I have written down the outcome. After deducting, I have noted down the outcome. After doing this, I'll be going for column operation. What is column operation? Column operation is nothing. From each column you have to identify 0. From each column you have to identify 0. Okay. And same way, suppose if I'm, small number. From each column you have to identify small number. After identifying small number from each column, subtract that small number from respected column. Okay. So same thing I did. After identifying small number from each column, each column, I subtracted that from the respected column, and here is my next matrix. After that, what I'll try to do is I'll try to find allocations, that here there is 1 0, here there is 1 0. Okay. Here I'll give you one more rule. What is the next rule? There should be 1 0 in each row and each column. That means if I highlight this 0, for example in row B, if I highlight this 0 is useless for me. Okay. That means here if I highlight, I am selecting this allocation, right? So suppose this A is allocated to B. Okay, it's salesman is allocated to job B. So I cannot take this. Matlab one salesman, one job is assigned. I cannot take that again. Okay. So this is useless. So once I allocate here, okay, entire row and entire column is useless for me. Once this allocation is done here, then this entire row and entire column is useless for me. Right? That way each row, each column, each row and each column. Okay, each row and each column should have 1 0. After doing this, if you are not able to, here in my matrix, I was not able to do that. Each row, each column 1 0. Then what I did, I prepared one more matrix. Okay, I improved my matrix. How I did that? By drawing minimum lines. Okay, after drawing minimum lines, how to draw minimum lines? Your minimum lines should cover all zeros. Come se come, draw minimum lines and cover all zeros in your matrix. Diagonally not allowed. Vertically and horizontal lines only you can draw. Draw minimum lines and cover all zeros. Okay, draw minimum lines and cover all zeros. After doing that, okay, so now each row, each column, that is done. You want each row, each column. Now I was not able to do that. Okay, my last row and last column I was not able to assign. So what happened? I went for improved matrix. Okay, I went for improved matrix. Now what I'm supposed to do here for preparing improved matrix? Draw minimum lines. Okay, I'm supposed to draw minimum lines. Now these lines should be drawn in such a way that all zeros should be covered. Okay, these lines should be drawn in such a way that all zeros should be covered here. So for covering these zeros, all zeros should be covered here. So for covering all zeros, you have to draw vertical lines and horizontal lines. Diagonal lines not allowed. Kam se kam, minimum lines you have to draw. Done. After doing this, identify smaller number from uncovered area. See, this is my uncovered area. Identify smaller number from the uncovered area. This is my uncovered area. This is my uncovered area. Okay, identify smaller number from uncovered area. Okay, after identifying smaller number from uncovered area, you subtract that smaller number from all the uncovered part and add that smaller number to intersection. Okay, subtract that smaller number from the uncovered area. Okay, this is my uncovered area. See, I have shaded that. This is my uncovered. So subtract from uncovered area and add back to intersection. Okay, add back to intersection. Done. So once you do that, you will get your final matrix. Okay, and you will be able to allocate all your allocations. Okay. After doing this, see, if you can see, each row there is 1 0, each row 1 0, each column 1 0. No rows and no columns should be repeated. Each row 1 0. See, here I have assigned zeros and here no other allocations. Here I have assigned 0, no allocations. Here there was 0. I have selected that, this becomes useless. I have selected this becomes useless. Getting? I have selected this becomes useless. So I have made allocations. Now after doing this, what you have to do? You have to give your final answer. So see how I have done. I have noted down this also. I'll show you. So I have noted down this way: A, B, B, E, E, C. So how to note this? So here you have A, right? Here it is from, and this is to. So from A to B, right? So that same thing I have written, from A to B. Then from B to E. Okay, same thing I have written, from B to E. Then you have from C to D. Okay, from C to D. Same thing I have written here, from C to D. Okay. Then you have from D to C. From D to C. So same thing noted down, D to C. Okay. Then